All right, let's talk AWS Transit Gateway. If you've kind of used it before, but you're ready to go from being just a user to a real expert, well, you're in the right place. Seriously, in just the next few minutes, we're going to level up your TGW game completely. Let's get right into it.
So here's what we're going to cover. We'll kick things off with the 3 foundational routing models. Then, we'll get into a really cool trick, mastering the Blackhole route. After that, we'll look at building some serious enterprise designs, connect our networks across the globe, and wrap up by looking at the common mistakes that can really trip you up.
Okay, first up, the 3 core routing models. You really got to know these. Think of them as your essential building blocks. Pretty much every transit gateway setup you ever build or have to troubleshoot is going to be based on one of these fundamental patterns.
Yep, that's it, just 3. And these are the ones you'll see over and over again, both on AWS certification exams and, more importantly, in real-world production networks. If you can get your head around these 3, you'll understand the whole philosophy behind Transit Gateway.
So let's start with a really common business problem. Imagine you've got a bunch of different departments, right? And each one has its own VPC. For security, you've got to keep them separate from each other, but they all need to be able to reach some central resource, like your on-premises data center. How do you pull that off?
The answer is the classic hub and spoke model. It's beautiful in its simplicity. The Transit Gateway is your central hub. Each VPC is a spoke, and it can only talk to the hub, say to get to your on-prem network over a direct connect. But, and this is the crucial part, the spokes can't talk to each other. This gives you fantastic, built-in isolation, which is just perfect for things like multi-tenant apps or if you're building out a zero-trust network.
Now let's flip that completely on its head. What if your goal isn't isolation at all? What if you want total collaboration? Maybe you have a big dev environment where all the different teams and services need to chat with each other freely across a bunch of different VPCs. How would you build that?
For that, we've got the full mesh model. Just like it sounds, every VPC that's connected can talk to every other VPC. What's interesting, though, is that this isn't the default. You, as the network architect, actually have to go into the Transit Gateway route tables and manually set this up. But that's a good thing. It gives you really fine-grained control. It's the ideal setup for those shared services or wide-open dev environments.
And scenario number 3 is a big one. This is a non-negotiable requirement for almost any large company: security. The mandate is clear. Every single packet, whether it's moving between VPCs or heading out to the internet, has to pass through a firewall for inspection. No exceptions.
We solve this with the inspection model. This whole architecture is designed to funnel every bit of traffic through one central, dedicated firewall VPC. By creating this single choke point, you can deploy some serious next-gen firewalls and do deep packet inspection on everything. For any organization that's serious about security, this is the gold standard. So let's just quickly recap that. Hub and spoke is all about isolation, so VPC to VPC is blocked. Full mesh is for collaboration, so it's allowed. And the inspection model is for security, meaning all traffic has to go through a firewall. 3 different models for 3 very different needs. Simple, right?
Okay, time to level up. Let's talk about the Blackhole route. Now, I know that sounds like something's gone horribly wrong, but for an expert, it's actually one of the most powerful tools you have for security and keeping your network stable. Honestly, knowing how to use this is what separates the pros from the beginners.
So what exactly is it? Well, a Blackhole route is just a route you create in your TGW route table that points nowhere, to an attachment that's invalid or doesn't exist. Now, when a packet comes along that matches this route, what does the Transit Gateway do? It just drops it. Poof, gone. It doesn't try to find another path, it just silently discards it. And this isn't an error, it's something you do on purpose. And here's where it gets really powerful. First, you can stop catastrophic route leaks. Let's say your on-prem network accidentally advertises a default route to AWS. That could take your whole cloud network down. But if you have a Blackhole route ready, it just drops that traffic and saves the day. Second, you can reserve IP space. Just Blackhole CIDR range, and you've effectively told everyone, this range is off limits, don't use it. And finally, it's the official AWS recommended way to isolate 2 VPCs. You never want VPC A talking to VPC B? Just create routes that point them to a Blackhole. It's clean, simple, and incredibly effective. So now we've got the core models down and we know about the Blackhole route. Let's put it all together and talk about building a real enterprise network. Specifically, how do we do that centralized firewall thing we mentioned, but in a modern, scalable way? Let's take a look. The old way of doing this was called a transit VPC. You'd basically spin up some EC2 instances and run firewall software on them. And it worked, but it was often expensive, and it really didn't scale very well. The modern approach, the one AWS recommends today, is to use the Gateway Load Balancer, or GWLB. Think of it as a transparent traffic cop that sits in front of a whole fleet of firewall appliances from vendors you already know, like Palo Alto or Fortinet. It's highly available, it auto-scales, and it's way more cost-effective. It's a real game changer.
So, our network is secure and scalable, but what if it's also global? I mean, lots of companies have stuff running in more than one AWS region. Well, Transit Gateway has a fantastic feature for this called Inter-Region Peering. It lets you link your networks together using Amazon's own private global backbone.
The advantages here are huge. Your traffic never has to go over the public internet. It stays on the super fast, low-latency AWS network. It's way more reliable and performs so much better than a VPN. But, and this is a big but, you have to remember this one critical limitation. TGW Peering does not support transitive routing. What that means is a VPC in, say, Region A can't use the TGW in Region B as a stepping stone to get somewhere else. It's a direct connection between the two TGWs, and that's it.
All right, last section, I want to share some hard-earned wisdom here. These are the common pitfalls, the little gotchas that can cause major headaches down the line. Knowing these things ahead of time is going to save you a world of pain.
First things first, remember that bandwidth isn't infinite. When you attach a VPC to a transit gateway, AWS creates one network interface, an ENI, in each availability zone you're using. And that single ENI has a hard bandwidth limit. People miss this all the time. You can't just add more ENIs to that attachment to get more speed. You have to plan your architecture around this physical limit right from the beginning.
Now this is so important. Please burn this into your brain. The route tables inside your transit gateway and the route tables inside your VPCs are two totally separate worlds. They do not talk to each other. If you make a change in the TGW, it does not automatically show up in the VPC. You have to manage both of them. I can't tell you how many hours have been wasted troubleshooting an issue because someone forgot this.
Here's a simple one, but it'll stop a project dead in its tracks if you're not ready for it. You absolutely cannot attach two VPCs to the same transit gateway if they have overlapping CIDR blocks. Think about it. The routing would be impossible to figure out, so AWS just says no. This is exactly why having a solid IP address management plan from day one is non-negotiable in the cloud.
And we're going to say it one more time because it applies everywhere, not just with peering. Transit Gateway does not do transitive routing. A packet can't take multiple hops through the TGW to get where it's going. You can't go from VPC A through the TGW to VPC B and then try to go back through that same TGW to get to your on-prem network. It doesn't work like that. Every route has to be a direct shot from source to destination with the TGW in the middle.
So there you have it. We've gone through the core models, the power of the Blackhole route, modern firewall designs, and the big pitfalls to avoid. You now have the expert-level foundation for Transit Gateway. But the question is, what's next? Are you ready to dive into even more advanced stuff like multicast, the high-availability appliance mode, or designing for complex failure scenarios? Because the learning never really stops. Thanks for watching.